This is our review for Chapter 5. We're going to start by taking a look at this problem right here. Factor x to the 7th plus 7x to the 6th. They both have this x to the 6th. That's our smallest number right there. So our factorization is going to be x to the 6th. We pull that out and we're left with x plus 7. That's our factorization, and if we want to multiply it, we'd multiply x to the 7 plus 7x to the 6th. Hey, look at that, it checks out. Next, we have this problem right here. We're going to factor x cubed times the quantity x plus 1 plus 9 times the quantity x plus 1. Both of these have a factor of x plus 1. So that's going to get factored out. What will remain is the x cubed and that plus 9. X plus 1 times the quantity x cubed plus 9. Now problem. Factor the trinomial c squared plus 12c plus 32. We're going to take Number 3, we're going to factor c squared plus 12c plus 32. We need to go ahead and factor 32. And let's see here, we've got 1 plus 32, that's 33. No. 2 plus 16 is 18. No. 3, nope. 4. Let's see here, 4 plus 8 is 12. Yep, that's it. This is going to be equal to c plus 4 times c plus 8. That's our factorization. Great. Next, we're going to do the same thing here with b squared minus 6b minus 27. We're just going to take our negative 27 and pull it apart. So we could have plus 1 minus 27. Nope, that's a negative 26. We could have plus 3 minus 9, that's a negative 6, so that's what we want. B plus 3 times b minus 9. Great. And then last on this page, we're going to have r squared plus 9rg plus 20g squared. And it's 20 is going to be what we're looking at here. So 20 pulls apart into 4 plus 5, right? 4 times 5 gives us 20. 4 plus 5 is equal to 9, which is this middle term. Now what about the g squared and the r squared and all of that? Well, we treat them the same, and we'll just take the r, we'll write it there, and it'll be plus 4g. There's a factor of g in there. We split the g up into the front and the rear, plus 5g. So there's some g up front, there's some g in the back. Just like there's some r up front and some r in the back. Great. Let's factor 2x squared minus 13x minus 7. Now in this case, since we've got a 2 up here, we're going to need to use the AC method. AC in this case is 2 times a negative 7, which is equal to a negative 14. We need to make a negative 14, take that and break it apart into two factors that multiply to negative 14, like a positive 1 and a negative 14, and then they need to sum to a negative 13, like 1 and negative 14 do. Then we'll take 2x squared minus 13x minus 7, and we break apart that negative 13x into minus 14x plus x, minus 14 plus 1. My trick is always to put the negative first. This becomes 2x times x minus 7 plus x minus 7. And there's a little commonality there. X minus 7. We can factor that out. And we'll have x minus 7 times 2x plus 1. Great, and we've factored that. Now we've got to factor this trinomial, 6y squared plus 34y minus 56. And I'm going to notice right here that 6 is divisible by 2, as is 34, as is 56. So I'm just going to start by pulling a 2 out of everything. So that's 2 times 3y squared plus 17y minus 28, I believe. Now we're going to take 3 and 28 and do the AC method with them. 3 times a negative 28, which is, let's see here, 4, negative 84. And we need them to add up to 17, right? That could be something like negative 1 plus 84. No. Negative 2 plus 42. No. Does 3 go in there? It does. So like a negative 3 plus 2 and 8. So 28. No. We could have negative 4 plus 21, which is a positive 17. I think that's what we're looking for. Okay. So we're going to have 3 times the quantity 3y squared minus 4y plus 21y minus 28. All right, and now we factor the front here. So this is going to be 3 times, we can just pull out a y. So that's y times 3y minus 4. In the rear, we can pull out a 7. So that's plus 7 times 3y minus 4. Hey, it matches. That's great. So here's our little match. 3y minus 4. And I don't need these big brackets anymore. So it's 3 times 3y minus 4 times y plus 7. Wow, that was a long one. All right. Next problem. We're doing more factoring here. This says factor by grouping. And I'm going to rewrite this as 6d squared minus 5d minus 1. And AC in this case is equal to 6 times 1, or negative 6. So we're going to break it apart and do a negative 6 plus 1. Gives us negative 5. So this is equal to 6d squared minus 6d plus d minus 1, which is 6d times d minus 1 plus d minus 1. So we get 6d plus 1 times the quantity d minus 1, c, right? Plus minus 6, yep, c. All right, factor by grouping. 8d squared minus 7, AC is going to be a negative 56. Let's start working through some pairs of factors. Plus 1 minus 56, no. Plus 2 minus 28, no. Does 3 go into there? No, but 4 does. Plus 4 minus, I think it would be 14. Yeah, 14. That's going to be a negative 10, so we're close. 5 doesn't go in. 6 doesn't go in. 7 goes in, so that's plus 7 minus 8. That's a negative 1. And then after that, we're at plus 8 minus 7. There's a positive 1, which is not... That's not negative 2. That can't happen. So I guess the trinomial is not factorable. Huh. Let's factor r squared minus 14r plus 49. I'm looking at the end here, and I'm looking at that 49, and I'm saying, hey, this is 7 squared. So I'm thinking perfect square. I'm thinking it's going to be r7 squared. Now I need to check the middle here. I've got minus 14r. This is minus 2 times the 7 and the r. The 2 is important. It should be the 2, basically because it's squared. And then that negative tells me I need to subtract. And if I'm not sure of myself, I'm just going to do r minus 7 times r minus 7 and get r squared minus 7r plus 49. R squared minus 14r plus 49. Cool. That's what I started with. So this, r minus 7 quantity squared, is my factorization. Now, we want to determine whether the expression is a difference of squares. Difference. Minus sign. Check. Squares. I have s squared and I have 7 squared. Check. Is it a difference of squares? Yes. And what would it equal if I was to factor it? It would be s plus 7 times s minus 7. Great. Let's factor this difference of squares completely. We're going to take the square root of 49a, 49a squared, so that's 7a. And we're going to take the square root of 9g, so that's plus 3g, and 7a minus 3g. Look at that. It's all good and factored. This one is harder. This is not a difference of squares, but a difference of cubes. I take the cube root of a cubed. I subtract from it the cube root of 27. A cubed, 3 cubed. Now, a cubed divided by a is a squared. Negative 27 divided by a negative 3 is a positive 9. What goes in the middle? Negative 3 times a. Well, positive 3 times a. And I know it's positive because these signs need to be opposite so that I can get some cancellation. And if I want to confirm this, I'm just going to FOIL it all out. And if I had my signs wrong, I would have seen that there wasn't the right cancellation. And I wouldn't have gotten a cubed minus 27. Canceling. All right. Uh-oh. Let's factor this thing. Well, w to the 6th minus 64. I'm going to treat this as a difference of cubes. Difference of cubes? Or a difference of squares? That 6 is throwing me. Let's treat it as a difference of squares. Let's treat this as w cubed squared minus 8 squared. Then we're going to get w cubed minus 8 times w cubed plus 8. W cubed minus 8, why that factors? That's going to factor into w minus 2 times w squared plus 2w plus 4. And then on the back here, w cubed plus 8, that factors into w plus 2 times w squared minus 2w plus 4. All right. And that's our factorization for that one. what if we'd have factored it as cubed first? Then we would have gotten w squared minus the cube root of 64 is 4 times w to the 4th minus 4w squared, or plus 4w squared plus 16. And this would break apart up front to w minus 2, w plus 2, and then this, goodness, I don't think I would have seen that this breaks apart into these two right here. That quartic, fourth degree one. I don't think I would have seen that happening, but it does. Now I'm just indulging. W to the 4th minus 2w cubed plus 4w squared plus 2w cubed minus 4w squared plus 8w plus 4w squared minus 8w plus 16. We get w to the 4th. Those cancel, those cancel, those cancel. Plus 4w squared plus 16. Oh. So I guess we should break it apart by that squared first, or else we're going to miss some factors. Factor completely. 175 minus 10b minus 5b squared. Well, before I factor completely, I am going to rewrite this in a friendlier fashion. Minus 5b squared minus 10b plus 175. And I'm not done yet. Everything can take a negative 5 out of it. This is negative 5 times the quantity b squared plus 2 minus, let's see here, 35, right? Yeah, that checks out. B squared plus 2b, pardon me, minus 35. Well, negative 7 times a positive 5 is a negative 35, but they sum to negative 2. A negative 5 times 7 is negative 35, and negative 5 plus 7 is a positive 2. This factors into negative 5 times b minus 5 times b plus 7. Great. 16. Factor this trinomial. 25 has as factors 1 and 25, but that adds to 26. 5 and 5, but that adds to 10. So the trinomial is not factorable. Now we have to solve using the principle of zero products. I'm going to take t, I'm going to set it equal to 0, and I'm looking for t being equal to 0, so that's one solution. I'm going to take my next one right here, 4t minus 5. I'm going to set it equal to 0. That means that 4t has to be equal to 5, which means that t is 5 divided by 4. Then we're going to take the last one, 5t minus 1, set it equal to 0. Find that 5t must be 1, or that t must be 1/5. So we end up with t equaling 0, 1/5, or 5 over 4. Let's solve this. We've got c squared minus 4c is equal to 30 plus 3c. Everybody needs to get over to that side. So I'm going to subtract 3c from both sides, and we'll get c squared minus 7c. I'm going to subtract 30 from both sides. C squared minus 7c minus 30, and that's equal to 0. Now, let's see if we can factor 30. I think we can. C minus 10 times C plus 3. I think that's the factorization we want. Then, 10 minus 10 is 0. Negative 3 plus 3 is 0. So, C is equal to 10 or a negative 3. Great. That'll do it for our Chapter 5 review.